All of you keep waiting. Next one, we are going to see what is the difference between evaporation and as well as boiling. That is what we'll say, evaporation versus boiling. So we all know that forget about the boiling or evaporation. Both the process will do the same work. What is the common work done by them? Everybody? Both they will convert liquid state of matter into what state? Everybody?
Yes.
Gaseous state. Of course, evaporation, we all knows that it is a continuous process and it is the it will take place at all the temperatures, but boiling is a temporary process which will only takes place at where? Only at boiling point. So, like that, so many differences I have told you. And evaporation leaves you what? So many examples I told you. Evaporation leaves you cooling. But boiling, it will never be. Like that, many examples we studied. So let us discuss now all the things, everything. What is the difference between boiling and evaporation? But of course, what is the main function of them? Both process will convert liquid into what? Liquid to gas. So boiling is an evaporation. Boiling is an evaporation process, but evaporation cannot be boiling always. Am I right, everybody? True or not?
Yes, sir.
Yeah. So that is what I can say. So boiling, I can say it is an evaporation process because it is a temporary. So boiling is an evaporation process, but evaporation is not an
Temporary.
boiling process. Understanding? But evaporation,
Sir, we need to write in tabular column only.
yeah, I will say you wait, cannot be boiling always. Is it okay, Mari? Just we are writing it. Okay.
Yes.
Next only we'll proceed with the tabular column. So boiling is an evaporation process, but evaporation cannot be boiling always. Okay. Now let us see that. What is the differences between evaporation and boiling? So you can construct the tabular column. So I will construct the tabular column with a 3 by 3 matrix. You can construct. So 3 by 5 we can construct if you want. Okay. So I'll make it here. Okay. So I'll write neatly. You also write it. This is very, very important. Okay. Definitely they will ask you in even exam also. 3 by 5 matrix I'll construct. I'll make it everything 2 lines, 3 lines, so that I can write it. Okay. First box is parameter. Second box is evaporation. And the third box is what? Everybody? Boil. Okay. So that is what. Let me insert this. Okay, everybody clear? So this is the tabular column. What is the heading you have to keep, Amma? What is the heading you have to keep? Differences between evaporation and boiling. Okay. So first one is serial number. Next one is 0.1, 0.2, parameter 0.3 and as well as 0.4. So parameters. What is the parameters differences? We'll discuss it. See, all people will write differences mean only so directly, but here we are representing parameters. So by seeing these, people will understand it. That is the reason. Okay. So parameters, first one is, we'll say what? Everybody. It is the evaporation and next one is what? Boil. Okay. Clear, all of you? Yes. Can you hear me?
Okay.
Yeah. So first parameter, you can write it. Temperature. So tell me, it will take place at any temperature or only takes place at a particular below any temperature or a particular temperature? Everybody?
All
Evaporation takes place at all temperatures.
Yes. That is what the first thing. Can takes place at any temperature. Can takes place at any temperature. And evaporation is a surface phenomena or throughout the liquid? Everybody?
surface phenomena.
Surface phenomena. Okay. So it is a surface phenomena. Next, boiling is a process which will take place at what? Only at a constant temperature. That point is called as what? Everybody.
Boiling point.
That is what? Which will take place at a constant temperature. That constant temperature only what we used to call? Everybody?
Boiling point.
Boiling point. Temperature called BP. BP means what?
Sir, we
Boiling.
should say it as a surface area only, no, sir?
No, it is not surface. How it will be surface phenomena? It will be throughout the liquid. As it is or no?
Sir, no, sir. In evaporation, I'm asking, sir. In
Yeah,
evaporation.
evaporation surface phenomena. It is surface
Sir,
phenomena.
we no need to say surface mean, sir.
Surface phenomena. Surface
Surface
only.
area.
Yeah. Okay.
Yes, sir. So we
Yeah.
can't say surface area, sir.
Surface area, not surface phenomena. Only at the
Yes, sir.
above the liquids. Okay.
Yes, sir.
Yeah. Clear?
Yes, sir.
Yeah. So now, so it is a bulk phenomena. Here you write. It is only surface phenomena. It is here. It is a bulk phenomena. Phenomenon, which means all the particles take part in the boiling. Which means all the particles take part in boiling. Is it okay, everybody? That is the point number 1. Understand, all of you? Second. Sanjay, second one what? Nature. Second parameter. Okay. So that is only actually we have written here. So this point only, that is why I mentioned, do one thing, merge this both. Nature and temperature and nature, both you can write together. So temperature and nature, parameter 1. So it can take place at any temperature. And what is the nature? It is the only what phenomena?
Surface phenomena.
And which will take place at constant temperature, which is called as what? What is the constant temperature, everybody?
Bulk phenomena.
Boiling point.
Boiling
And it is a
point.
bulk
Boiling point.
phenomena. Okay, nature. Second one, cooling. Second one is cooling. Yeah, tell me. Evaporation causes cooling or boiling causes cooling? Everybody. Yes, please.
Evaporation causes cooling.
Evaporation causes cooling. Evaporation causes cooling. But boiling, what will happen? No cooling. No cooling caused by boiling. Am I clear? Everybody understood?
So doubt, sir.
Yeah, tell me, Mari.
Sir, in boiling, the first one, temperature, it is a bulk phenomena, which means all the particles
take part in boiling.
Yes, sir.
Lingesh, Puriyamara, Nivedan.
Yes, sir.
Yeah, who is missing? Gokul Raj is missing. Kishore is there? Kishore? No. Kishore, Agalya. Okay. So everybody clear? Cooling. Next. Rate. So who is a fast process? Rate. Rate means speed, guys. So it is a faster rate which will decide what?
Evaporation.
Yeah, it can be different. Sometimes it will be faster, sometimes it can be slower. Based upon the what? Based upon the temperature. Understanding? So slow or fast at different temperature. Am I correct, guys? All of you?
Yes, sir.
Yes, please. We have studied that factors affecting the evaporation, rate of evaporation. What is that? Sunny day, windy day, rainy day. Yes or no, guys? Like that? All of you?
Yes, sir.
Yeah, that is what. So rate of evaporation can be slow or fast at different temperatures. But here, what is happening? The speed of boiling remains same, but the conversion of liquid into gas based upon becomes fast at the high temperatures. So always it is, remember, write it. The speed of boiling remains the same. The speed of boiling remains the same because we are providing the same heat energy. Yes or no, guys? All of you, same, but the conversion of liquid into gas becomes faster at high temperatures. Okay?
Sir,
Yes.
sir, in evaporation, below the boiling 100 degrees Celsius itself, it will
That is
evaporate.
only for water, Mari. Don't use 100 degrees Celsius. If you use boiling point,
Yes.
it is right. But why are you using 100 degrees Celsius? I don't know.
Okay.
If you are using
Yes.
100 degrees Celsius, it is wrong.
Yes,
Understand?
sir.
Because it is a
Yes.
boiling point of what, guys? It is a boiling point of only water. You should not use it everything
Sir,
for
then means evaporation, the rate of evaporation will be faster and it will be below than a substance boiling
rate of
point, sir.
evaporation, who said faster? It may be a faster or slower based upon the atmospheric temperature. Understand?
Yes.
Yeah.
Yes, sir.
But boiling, we are providing the temperature. That is why I am saying it is remains same, the speed. But if you increase
Yes.
the more heat energy, more fast it will take place. That is all. Understand? That is.
Yes, sir.
Yeah. Next, fourth one. Effect of physical conditions. Ma, you are not supposed to use boiling point means 100 degrees Celsius. That is an example alone. Boiling point of 100 degrees Celsius only for what? It is only for water, not everything. Remember that. Okay. Now, effect of physical conditions. Tell me, guys, who will affect the evaporation rate? So many things we studied. Now you should tell me. What is the effect of evaporation? Rate of evaporation. Sanjay, I'm expecting from you. Mr. Sam, Sanjay, Lingesh. What is that rate of evaporation changes by? Girls, Agalya, rate of evaporation changes by, what is that, guys?
Sir, temperature,
By
Temperature,
changing temperature. Next,
surface area,
surface area,
very good, surface area. Next,
humidity of
of
the
the
air,
air.
humidity, that is what, wind speed, humidity, etc. Am I right, everybody?
Sir, nature
Yes,
of
sir.
the liquid.
Nature of
Nature of the liquid. That is what, volatile or non-volatile. Yes or no?
Yes, sir.
Yes,
Sunny,
sir.
that is what. So, but if you take boiling what? It does not depend on external factors. Only heat it will depend. Understand, guys? Everybody? Yes, please. It does not change with the change in normal temperature. Understanding external temperature. That is what not, change in external temperature, surface area, and wind speed. External temperature, surface area, etc. So this is the differences between boiling and evaporation. I hope you all understand. So you have to learn very, very perfectly. Very, very important. Even to 2 more questions, so many times they will ask you. So all of you remember the evaporation affected by the 5 factors. What is the 5 factors? Everybody, let me say first factor, temperature. Second factor, surface area of the liquid. Third factor, humidity of air. Fourth factor, speed of wind. And last factor, what is that, guys? Nature of the liquid. That is what effect. Like evaporation is affected by that 5 following factors. What are the 5 following factors, everybody? First one is what? All of you. Temperature. Second one, respond. What are these people?
Sir, the second one, surface area.
Surface area of what? Surface area of the liquid. Remember, Lingesh, for example, the tea is kept in a cup and the tea is poured in a where? Saucer. That is. Next, everything you have to remember one example. Third one, humidity of air. Okay. Now, fourth one, speed of wind. Speed of wind. Next, fifth one, what is that? Nature of liquid. That is only we can say volatile liquid or non-volatile liquid. Yes or no? So who will evaporate faster? Low boiling point liquid or high boiling point liquid? Everybody.
Low boiling point.
Low boiling point liquid. That is what you have to remember. Okay. So this is what about it. Now let us all of you take everybody take your
Sir, wait a minute.
yeah, complete it fast. Till here completed, let me know. So once it is over, then we are going to start now. Exercise, we'll try to complete it. So all the in-text questions, everything you have to answer it. So now if you come to here, exercise, all of you take your book. So we are going to finish it fastly. We are having only 9 questions. I will complete it. So first one, convert the following temperatures to the Celsius scale. So very simple for you people. First, tell me the relation. Converting from Kelvin to Celsius. What is the relation? Anyone can tell me? Converting
Sir, Kelvin
from
is equal
Celsius
to
to
C plus 273.
C plus or C minus हमारे Kelvin to Celsius. Degree Kelvin is equals to any relation, anybody? Degree to Kelvin. I want to know who will say first. Let me see.
So minus 273.
That is what you have to remember. So all of you check it. Kelvin, first write the relation. We all knows that Kelvin is equals to, what is the formula? Respond. Degree Celsius plus 273. Now, this is for what? Converting from degree Celsius to Kelvin. Am I right or wrong? All of you? Yes,
sir.
please. But what they have given here, they have given the Kelvin and we have to find it in what? We have to find in the degree Celsius. So reverse. So we have to find degree Kelvin to degree Celsius. So what is the relation, everybody? Degree Celsius is equals to Kelvin minus 273. Am I right or wrong? All of you. So if you want,
Yes,
you can
sir.
take even more efficient. 273.15. 273.15. That is what. So now that's all. This is the relation. So which relation we have to use? First one or second one? Everybody. Second one. Understand? Learn it. Kelvin to degree Celsius. Degree Celsius to Kelvin. So respond now. 293 Kelvin means in the sense of what? Degree Celsius is equals to 293 minus 273.15. Do it and tell me the answer fastly. Fastly, everybody.
20.15 Celsius.
20 point. Others don't know. 293 minus 273.15, which is equals to 20 or 19.8.
20, sir. Sir,
Ah.
20 degrees Celsius.
20.15 degrees.
19.85.
85.
Mr. Nimesh, Nivedan, wrong answer. So 19.85 degrees Celsius, that is the answer. Or if I use just only 273, so what is the answer? Kelvin minus 273, which is equals to 293 minus 273, which is equals to how much, Ra? 20 degrees Celsius.
20.
Understand, Nivedan? Not 20.15, 19.85. Understand, Lingesh? Very good. So that is what. Next, 470 Kelvin. So that what will happen? 470 minus 273.15. If you want, you can take 15, or else don't want means you can remove it. Nothing wrong in that. So 470 minus 273.15. Everybody, what is the answer? All of you? Which is equals to 196.85 degrees Celsius. Or approximately you can equals to what? All of you? 197 degrees Celsius. Okay, guys? Everybody? Clear? Understand?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, that is the first question. Second question, convert the following temperatures into Kelvin scale. So we have to use first relation or second relation?
First relation.
First relation. Very good. Proceed fastly now. What is that? 25 degrees Celsius. So convert it. So Kelvin is equals to 25 plus 273.15. That's all. What is the answer? Amma?
298.15.
298.15 Kelvin. That's all. Okay, second one. 373 degree Kelvin. So Kelvin is equals to 373 plus 273.15, which is equals to how much? 646.15 Kelvin. That's all. Finish it fastly, everybody. Others, everybody able to solve it or not? Mr. Lingesh, Alfin, Sanjay, Pranav. What happened to Kishore Lingesh? Call him. Okay.
Yes, sir.
That is what. Very good. Next. Completed. Respond, guys.
Yes, sir.
Next.
Yes,
They're
sir.
asking, give reason. Very, very important. Give reason for the following observations. Naphthalene balls disappear with the time without leaving any solid. What is this? Actually, naphthalene balls are what?
Solids.
They are actually solids. They're directly converting into disappear.
Sublimate.
They're
Sublimate.
converting from solid to gas directly without forming any liquid. Means in the sense of, what is that called as?
Sublimation.
Sublimate product.
They are actually sublimate. Understanding? Sublimate substances. So, sublimate substances means, we all knows that under sublimation, directly solid will converting into what? Slowly it will diffuses into where, guys? Slowly naphthalene balls diffuses into where? Directly diffuses into where, guys? Into the atmosphere.
Into gas.
Atmosphere. Understanding? So that is what, without leaving any solid, slowly it will diffuse into the atmosphere. Can you use any scientific word? It is a sublimate product. It is a something XYZ not. So something is directly disappearing. So we can say something like evaporation. What is that? Anybody? It is a volatile solid or non-volatile solid? Everybody?
Volatile.
Volatile solid. That is the word I am expecting from you. So naphthalene is a what solid, everybody? It is the volatile solid. So having low boiling point or low melting point or high melting point. Everyone having low melting point as well as boiling point. So it will show sublimation even at what temperature? Even at what temperature, guys? Even at room temperature. Ellame clear? Respond ra.
Yes.
Even at room temperature, it will directly diffuses into atmosphere and disappears without leaving any solid. Ellame clear? Understood, guys?
Yes, sir.
Yes. Next, we can get the smell of a perfume sitting several meters away. That is what I told you. If you take, this is the one room. Now here you are spraying the spray. Even this, all the corners, other corners also it will spread. Why, guys? What is the reason? Because perfumes are highly, what it contains? Alcohol. So it is a volatile or non-volatile? All of you.
Volatile.
Volatile. That is what? Understanding? So perfumes are, what is there? They are highly volatile. Understand, Amma? So highly volatile liquid is present in that. So which will shows high rate of diffusion or low rate of diffusion? Everybody.
High rate of
diffusion.
High rate of diffusion. Even to the even at what temperature? Again. Even at
room
Room
temperature.
temperature. That is the common room temperature. So the perfume spreads up to long distance by mixing with the air, and we can smell it even from several meters away. Ellame puriyuma? Clear, guys? Everybody? Understanding, guys?
Yes, sir.
Yeah,
That's good.
that is what. Finish it fastly, everybody. Completed, guys?
Yes, sir.
Any doubt? Anyone?
No, sir.
Okay. So finish it till here. Next question. Next, arrange the following substances in increasing order of forces of attraction between the particles. Water, sugar, oxygen. Arrange them in order. We
Sugar,
have to
water,
arrange.
oxygen.
Yeah,
Sugar,
first will
water,
come.
oxygen.
First will come. Let me.
Sugar.
Here, two ways you can
Sugar.
arrange. That is what. Be smart always. Not only one way. Two ways we can arrange. From they are not asking increasing order. So they are asking, see, substances in increasing order of forces of attraction. Force of attraction should increase. So that what we can make. Everybody's. All of you. So we can write it in two ways. Oxygen, water, and sugar. That is what. Very good. First I will write. We know that it is a gas. Gas is having less. Next one is having what? Everybody. Liquid. Next one is having what? All of you respond, Ra? Solid. Understand, Ra? This is you should write first. You should say the statement that we know that the force of attraction among the particles increases from where to where? So gases to liquids, liquids to solids. Now you write it. So first one, gas. Who is the gas? Everyone here? Oxygen.
Oxygen.
Next one, liquid. Who is the liquid? Water. Next one, sugar. That's all. Finish it up. Clear?
Yes, sir. Yes, sir.
Do it fast. Do it quick now. Completed?
Yes, sir.
Completed, sir.
Yeah. Next question. Okay. So next question, read everybody. What is that? What is the physical state of water at 25 degrees Celsius? Everybody?
It's a liquid state, sir.
Liquid. Very good. At 0 degrees Celsius? Now you
Solid state.
gone. Gone. 0 degrees. Not only solid.
Solid.
Solid and liquid both, amma, because melting point is equals to freezing point. Ellame remember, Ra? So what will happen?
Yes, sir.
At 0 degrees Celsius, what will happen? It will exist at solid
Both
and
liquid
as well as what?
Liquid.
Liquid. Both. Do you all remember, everybody? That is. Next, 100 degrees Celsius also. Boiling is equals to condensation point, boiling point. So that what?
Liquid and gas.
Liquid and gas, yes. Purimara, all of you, that is what is very, very important. Okay. So be very careful. At any substance at melting point and boiling point, both the states of matter is present. Okay, guys? Yes.
Yes, sir.
That is what. Write it. Next. Give two reasons to justify water at room temperature is a liquid. What is the reason? First, let me see who will say first. Water is room temperature. Give two reasons to justify water at room temperature is a liquid. What is a, how you can say water is a liquid at room temperature? First thing, it does not have any. Water has its properties of liquids and does not have, like what we can say, has a boiling point above the room temperature. So you can tell me it does not have any fixed shape or fixed shape.
Sir, it doesn't reach us the boiling point, sir.
Yeah, first thing, no, does not have, how you can say it is a liquid? That is what I am asking. It does not have what? Fixed shape. Understanding? Purimara? Next, it has a fixed volume or not? Yenara, no response. Fixed volume or not? And if I pour that down, it will show the property. What is the property it will show? Fluidity. They asked two reasons. I given three reasons. What else you want it? That's all. Clear? Next. An iron almara is a solid at room
Sir,
temperature.
what is the first one, sir?
It does not have a fixed shape, Mari. Correct?
Yes, sir.
Yeah, Lingesh, no volatile. It is the okay, very good, Lingesh. That is also very good. Lingesh said one more point. It is not highly volatile. Very good. That is also. Of course, it is a volatile also, we can say liquid, but it's not a highly volatile also. We can say that also. Next, an iron almara is a solid at room temperature. Yes. What is the reason? It has a two things. Yeah, fixed shape and as well as what? Nivedan? Fixed shape
Fixed
and yeah, very good.
Sir,
Girls,
has more
very,
force
very
of attraction.
responsible.
Force of attraction.
Yeah. Next, it has a open surface or not? Everybody. And it is a very rigid in nature. You can write that is also. It is rigid in
So
nature.
we can write high force of attraction.
Yeah, high force of attraction, rigid nature. And it is incompressible or compressible in nature? Incompressible. Like that, they are asking only two. You can write many. Incompressible in nature. That's all. So any two reasons only they are asking. You can give so many. Next, why is ice at 273 Kelvin more effective in cooling than water at the same temperature? Super question. Is very, very important question. Anybody? See that 273 Kelvin means which is equals to how many degrees Celsius? Everyone.
0 degrees Celsius.
273 Kelvin is equals to 0 degrees Celsius. So now I have given, we all knows that at 0 degrees Celsius, just now we studied, matter is existed both what? Matter is existed
Freezing point.
solid as well as liquid.
Melting point and
At 0 degrees Celsius, we are getting water in ice form and also water in liquid form. So now tell me, if I put a water at 0 degrees Celsius, I put my hand, and water at ice if I carry. So which one you feel more cold? Anybody?
Ice.
Yes. Ice. Why, sir? Anyone? So who will absorb more heat energy? Liquid or ice? Who will absorb more heat energy from our body?
Ice.
Yes, all of you?
Ice, sir.
Ice, sir.
Ice.
Ice. That is what is needed. So who will absorb more heat energy from our body? Everybody? Ice. That is the reason we will feel more cool in 0 degrees Celsius ice compared to the water. Because liquid water already converted into liquid state. So it will take less heat or more heat? All of you?
Less heat.
Less heat. That is what. Write the statement for this question. Answer I will say you. Here I will write it. All of you write the answer. Question number 7. Shall I say it, everybody?
So one doubt, sir.
Yeah.
Sir, it is coolness because at 0 degrees Celsius, it can be in solid form also.
Yes, Mari. Solid one wants to convert into liquid so that it will take more heat energy from our body. That is why it will feel more effective in cooling. Understand?
Yes, sir. It leaves coolness, no, sir.
More cooling compared to 0 degrees. Suppose one hand you put 0 degrees Celsius water. One hand you put 0 degrees Celsius ice. So definitely which you are carrying ice will feel more cooling because to change its state, it will take more heat energy. Understand?
Yes, sir.
That is why. Write it. The ice absorbs more heat. The height absorbs. Write the answer neatly. My girls, understand, my girls? The ice absorbs more heat. Mr. Sam studying or not? Using phone? From the surroundings as compared to water at 273 Kelvin. 273 Kelvin is equal to how many degrees Celsius? Everybody? 0 degrees Celsius. Understanding? Now, the extra heat absorbed by ice in the form of latent heat of fusion. Therefore, 273 Kelvin. Okay. Therefore, 273 Kelvin, ice is more effective in cooling. Is it okay, guys? All of you? Yes.
Yes, sir.
Yeah. That is the answer.
Sir, you can say while it evaporates due to the temperature.
No
it
evaporates.
leaves
No evaporate. Converting into liquid.
Yes, sir. That converting to liquid, it leaves
needs
some
more
coolness.
heat energy to convert. It will absorb more heat energy from the body so that it will leaves more cooling. Okay.
It's like that also you can say that we
Yes,
can define
yes.
it.
Yeah. And see, this question is not new for us. I told you, if suppose I put a water at 100 degrees Celsius on your body, and if I put a steam at 100 degrees Celsius, which will causes more burning, everybody? Yes, please.
Steam.
Steam. Understanding? That is only, we studied or not while I'm teaching, I have told you or not. That is only next question.
Yes, sir.
What produces more severe burn? Boiling water or steam? Which will produce? Everybody?
Boiling water.
Boiling water. At what temperature? 373 Kelvin. Or we can say 100 degree. 373 Kelvin, or we can say what, guys? 100 degrees Celsius.
Kelvin.
Okay, 100 degrees Celsius. That is what it is. So write the answer. Meeting is going to end. We'll write the answer.
Sir, can you please down the screen, sir?
Yeah. Seventh question, you finish it. Then we'll write eighth and ninth question. Write it quick now. Complete it, everybody, fastly. Sanjay, understand, Sanjay? Okay. So meeting